So let us start doing worksheet questions. If that bracket denotes greatest integer function, that is step function, then the set of all real values of x for which the function is real. Indirectly the question is finding domain. If x is any real number, step x minus x by x minus step x, this is nothing but root of minus 1. If you take minus common, then both gets cancelled. It is root of minus 1, which is imaginary. So what are the real values of x for which the function is real? Means no real values. So answer is option A, null set. Next, the domain of real valued function f of x is equal to under root. First, the function inside the root should be greater than or equal to 0 and denominator should not be 0. Write factors for this. From this, x not equal to minus 1 by 3, x not equal to 2. Next, if a by b is positive, if a by b is positive, a into b is also positive, which means 2x square minus 6x plus 5 into 3x square minus 5x plus 2 should be greater than or equal to 0. What are the factors for 2x square minus 7x plus 5? Let us write factors for that. X into x minus 1 minus 5 into x minus 1. So this is 2x minus 1 into 2x minus 5 into x minus 1. And for this the factors are 3x plus 1 into x minus 2. This should be greater than or equal to 0. Draw a number line. So this is 1, 2, 5 by 2, minus 1 by 3. This is minus infinity, this is plus infinity. Now, for what values of x this product is positive, that you have to check. Take any number between 5 by 2 and infinity. 5 by 2 is 2.5. Take any number from 2.5 to infinity. Let us say x is 3. If you put x3 in here, positive, 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 so this will be positive. Next, between 2 and 2.5, if you take any number between 2 and 2.5, this will be negative. Take any number between 1 and 2, let us say 1.6, negative, positive, positive, negative. So this is again positive. Take any number between 0 and 1 and substitute here. Let us say 1 by 2. This is negative, this is negative, positive, negative. Take any number between 0 and minus infinity. Take any negative number. Then this will be negative, 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 negative. So this will be positive again. Now by looking this number line, where that product is positive means from minus infinity to minus 1 by 3, minus infinity to minus 1 by 3. Minus 1 by 3 is not included because x should not be minus 1 by 3. And union from 1 to 2, union 5 by 2 to infinity. So for 2 also open bracket. 1 is open bracket, 2 is open bracket. So option A is correct. Oh, sorry, here I wrote factors wrongly. Minus 6, minus 5x, minus 2i2. So it is, oh sorry, minus 2. Correct. Option A is correct. Next, the set of real values of x for which the function is real. Indirectly, again, the question is finding domain. As I said, to find domain of sum of two functions, you have to find individual domains and then intersection. When this will be defined? Logarithm is defined only for positive numbers. So 2 power x is greater than 2, x greater than 1. Here 1 minus x should be greater than or equal to 0, x less than or equal to 1. X greater than 1, less than or equal to 1. What is the number greater than 1 and less than 1? No number is possible. And for is equal to 1, this function is not defined because log 0 is undefined. So what is the domain means? Null set. Because there is no intersection for these two. There is no intersection for x greater than 1 and less than 1. So domain is null set. Option D is correct. Next, domain of the function. So inside the function, inside the root should be greater than or equal to 0. And in denominator, 4 minus x should be greater than or equal to 0. It is under root. X plus 4 should be greater than or equal to 0. From this, x less than or equal to 4. From this, x greater than or equal to minus 4. And if you write factors, how to write 5x? 9x minus 4x. So this is 3x into 2x plus 3 minus 2 into 2x plus 3. So 2x plus 3 into 3x minus 2 greater than or equal to 0, which means x less than or equal to minus 3 by 2 or x greater than or equal to 2 by 3. So these are the conditions for the given function to be defined. So it should be less than or equal to minus 3 by 2 but greater than or equal to minus 4, greater than or equal to 2 by 3 and less than or equal to 4. So what is the intersection of all these numbers? Option A. So what is the final domain? Less than or equal to minus 3 by 2 and greater than or equal to minus 4. So minus 4 to minus 3 by 2 union greater than or equal to 2 by 3 but less than or equal to 4. So 2 by 3 to 4. All values are included. So close the bracket for everything. Option A is correct. Next, the domain and range of cos x minus 3. Cos x is defined for all real values of x. So domain is R. And what is the range of cos x? Cos x range is minus 1 to 1. Subtract 3. Therefore range is minus 4 to minus 2. Close it. So domain is all real values. Range is minus 4 to minus 2. Option B is correct. Next, already in synopsis we explained this functional conditions. F of x plus y is equal to f of x plus f of y. The function which satisfies this condition is f of x is equal to kx. Therefore, what is f of 1? K, which is given as 10. Therefore, what will be f of x? 10x. And what is required? Sigma r is equal to 1 to n. F of r whole square. F of r whole square means 100 r square, because f of x is 10x, implies f of r is 10r. F of r whole square means 100 r square. That 100 can be taken out. Sigma r square, r is equal to 1 to n, which is nothing but 100 into 1 square plus 2 square plus so on up to n square. The sum of n natural numbers n into n plus 1 into 2n plus 1 by 6. So 250 is 2 3. So 50 by 3 into n plus 1 into 2n plus 1. Option C is correct. 250 times 2 3 times. Option C. Next, f of x is given, you have to find f inverse x. The procedure for finding inverse of any function. Let f inverse x is equal to y implies x is equal to f of y implies x is equal to y minus 1 by y implies xy is equal to y square minus 1 implies y square minus xy. This is a quadratic equation in y. Use minus b plus or minus root of b square minus 4ac by 2a. And y is nothing but f inverse x. F is mapping from 1 comma infinity to 0 comma infinity means f inverse maps from 0 comma infinity to 1 comma infinity. Now what is f inverse x here? X plus under root x square plus 4 by 2. And the other one is x minus root of x square plus 4 by 2. Now f inverse ranges from 1 to infinity. So out of these two, this value will be more than 1 always. In this domain, if you take any value for x from 0 to infinity and substitute here, the first one will be more than 1. And this, suppose if you take x is equal to 1, 1 minus root 5 by 2 is not more than. So f inverse x is equal to x plus under root x square plus 4 by 2 is correct. Option C is correct. Because if we look at f inverse domain and codomain, domain is 0 to infinity, codomain is 1 to infinity. So f inverse x is equal to x plus root x square plus 4 by 2 will be from 1 to infinity for the values of x which are in the domain. So option C is correct but not D. Now let us take a matrix A is equal to A, B, C, D. A, B, C, D are any real numbers. So I am taking 1, 2, 3, 4. Let us say. Then what is f of A as per the definition? Det A. What is det A? 4 minus 6, which is minus 2. Now I am taking another matrix like this. This is a different matrix from this. But what is f of A here? Det A? 4 minus 6 minus 2, which means different elements are having same image. I took two different matrices, but I got determinant as same. Therefore, the given function is not 1, 1. Because for function to be 1, 1, different elements should have different images. But here different matrices have same determinant, hence it is not 1, 1. Next, you have to check onto also, right? How determinant value of a matrix will be always a real number. Determinant of any matrix, determinant A is always a real number. What is codomain given? All real. So range and codomain are equal, so function is onto. So it is onto but not 1. Determinant A is always a real number because A, B, C, D are real numbers given. If A, B, C, D are real numbers, if you find that A, definitely you will get a real number. So what is the range of given function? All real. Codomain is given as all real numbers. So range and codomain are equal. And hence function is onto. Onto but not one. Next we have to find domain and range of inverse of x square. F of x is x square. Let f inverse x is equal to y. Therefore x is f of y. F of y is y square. Implies y is equal to root x. Now you have to find domain of this. What is domain of root x? Domain is x greater than or equal to 0, which means 0 to infinity is it. It is a domain of f inverse x. And what will be the range? F is mapping from minus infinity comma 0 to 0 infinity. So f inverse maps from 0 comma infinity to minus infinity comma 0. And we know that inverse exists only when it is a bijection. Bijection means it should be both 1 1 and onto. When we say that function is 1 1 and onto, when we say that function is onto, range should be equal to codomain. What is codomain? Minus infinity comma 0. So this is range and this is domain. Option A is correct. We know that inverse exists only when it is a bijection. Bijection means it should be 1 1 as well as onto. Onto means range should be equal to codomain. Codomain is this event. So range is equal to minus infinity comma 0. Option A is correct. Next, f is mapping from n to r. F of 1 is given as minus 1. And f of n plus 1 is 3 times f of n plus 2 for all n greater than or equal to 1. Now put n is equal to 1 in this. F of 2 is equal to 3 into f of 1 plus 2. F of 1 is already minus 1. So minus 3 plus 2 minus 1. Now put n is equal to 2. F of 3 is equal to 3 into f of 2 plus 2. So 3 into f of 2 is minus 1 plus 2. This is again minus 1. So I got f of 1 as minus 1, f of 2 as minus 1, f of 3 as minus 1 and so on. So f of anything is minus 1 means what is that function known as? Constant function. Option C is correct. Next question. F of x is equal to 5x power 4 plus 2 given. And we have to check whether the function is 1 1 or not. 1 1 or R2. Domain is given as R. F maps R to R is given. Domain is all real values. X can be taken any value. I am taking f of minus 1. Now I am taking f of 1. Elements are different. Elements are different, but image is same. Implies f is not 1 1. 1 1 means for different elements you should get different images, but here for minus 1 and 1 I got same image, so it is not 1 1. Now how to check whether the function is onto or not? By finding range and codomain. What is codomain given? All real values. But f of x can never be 0. Given function can never be 0, which means in range of f of x 0 will not be there. But codomain means all real values. So f of x cannot be 0 for any real value of x, which means Range of f of x doesn't contain 0, but codomain contains 0. So range is not equal to codomain. Implies f is not onto. So it is neither 1 1 nor onto. Given function can never be 0, but codomain is all real values which contain 0, which means range and codomain are not equal. So function is not onto. So it is neither 1 1 nor onto. Next, range of the given function. Given function can be written as x square by x, x by x, 1 by x, which means x plus 1 by x plus 1. And we know that if x is greater than 0, x plus 1 by x will be greater than or equal to 2. And if x is less than 0, x plus 1 by x will be less than or equal to minus 2. Therefore, if x plus 1 by x is greater than or equal to 2, what is x plus 1 by x plus 1? Greater than or equal to 3. From here, x plus 1 by x plus 1 is less than or equal to, add 1 on both sides, minus 1. So how the range of the function will be? It is greater than or equal to 3 or less than or equal to minus 1. Therefore, what is range of f of x? Less than or equal to minus 1 means up to minus infinity. Greater than or equal to 3 means up to infinity. For infinity minus infinity open, 3 is included, close the bracket, minus 1 is also included, close bracket. So this is the range of the given function, which is option 4, option D. For this you need to remember these two. If x is greater than 0, x plus 1 by x is greater than or equal to 2, and if x is less than 0, x plus 1 by x is less than or equal to minus 2. Add 1 on both sides because our function is x plus 1 by x plus 1. Okay. Next, domain of this function. This function is defined when 4 minus x square is under root function. 4 minus x square should be positive, which means x square minus 4 less than 0, x plus 2 into x minus 2 less than 0. From this, x lies between minus 2 and 2. And 1 minus x should not be 0, which means x should not be 1. So x not equal to 1 and x should lie between minus 2 and 2. So what will be the domain? X should lie between minus 2 and 2. Sorry, 1 minus x should be greater than 0 here because it is inside logarithm. One second. 1 minus x is inside the logarithm, which means it should be positive because logarithm is defined only for positive numbers. So 1 minus x should be positive, which means x should be less than 1. So what will be the domain? Lies between minus 2 and 2 and less than 1, which means minus 2 to 1. Both are open. Option C. X should lie between minus 2 and 2 and it should be less than 1, which means x lies between minus 2 and 1 with open brackets on both sides. Next, f of x and g of x, two functions are given and you have to find domain of f plus g of x. F plus g of x means f of x plus g of x. Already I told you, domain of sum of two functions is nothing but, say, there is a small mistake here. F of x is under root 4 minus x square. It is not 2 minus x square, it is 4 minus x square. G of x is log of 1 minus x. Already while discussing synopsis itself, I told you, domain of sum of two functions is nothing but intersection of individual domains. Find a domain for the first function. The function inside the root should be greater than or equal to 0, or x square minus 4 less than or equal to 0, x plus 2 into x minus 2 less than or equal to 0, which means x should lie between minus 2 and 2. Next, what is the condition for log of 1 minus x? Logarithm is defined only for positive numbers, so 1 minus x greater than 0 or x less than 1. Then what is the intersection of these two? Domain of sum of two functions is nothing but intersection of individual domains. So what is the final domain? Less than 1 and lies between minus 2 and 2 means between minus 2 and 1. 1 is not included, open bracket, minus 2 is included, close bracket. Option B is correct. Next, f of x is equal to x cube and g of x is equal to 3 power x. Then what is the quadratic equation whose roots are solutions of the equation f circle g of x is equal to g circle f of x. F circle g means f of g of x. G circle f means g of f of x. What is f of g of x? F of 3 power x. G of x cube. So what is f of 3 power x? 3 power x whole cube. What is g of x cube? 3 power x cube. What is a power m whole power n? A power m into n. So from this you get 3x is equal to x cube. Given that x is not equal to 0, so 3 is equal to x square, or x square minus 3 is equal to 0. Option D is correct. Next, f of x is given. You have to find f of x plus y plus f of x minus y. What is f of x plus y? Replace x with x plus y. What is f of x minus y? Replace x with x minus y. Now the question is finding f of x plus y plus, if we add these two, e power x plus y plus e power minus of x plus y plus a power x minus y plus a power minus of x minus y by 2. This is f of x plus y plus f of x minus y. And options are in terms of f of x and f of y again. So let us find f of x into f of y by multiplying both. So a power x plus a power minus y into a power y, a power y plus a power minus y by 2 into 2, 4. By multiplying the two factors, you get like this: a power x into a power y, a power x plus y plus a power x minus y plus a power minus x plus y plus a power minus x minus y by 4. Then what will be 2 into f of x into f of y? 2 into f of x into f of y means the 2 gets cancelled with 4 2 times. So what is left out? A power x plus y, a power minus x minus y is minus of x plus y plus a power x minus y plus minus x plus y is minus of x minus y by 2. So this left hand side term and this 2 into f of x into f of y both are equal. So option C is. Look at the next question. F maps R2R is defined as f of x is equal to 2 power 2020 whole power x by 2020 whole power x plus then sigma. Now for this you remember the shortcut like this. If f of x is equal to a power x by a power x plus root a, then f of x plus f of 1 minus x will be 1. Remember this. So given function is in this form, therefore f of x plus f of 1 minus x will be 1. Now the question is finding 2 times sigma, expand sigma by giving different values for our f of 1 by 40 plus f of 2 by 40 plus so on. In between you will get f of 20 by 40 plus like that. Last number is f of 4039. Before that 4038 will be there, plus f of 4039 by 4040. Listen this carefully. Now if this is x, 1 by 4040 is x, then what will be 1 minus x? 4039. This is 1 minus x. Similarly, if this is x, what is 1 minus 2 by 4040? 4038. This is 1 minus x, which means first term plus last term is in the form of f of x plus f of 1 minus x, which is 1. Next, second term from the beginning and second term from the end, that is also 1. This is also 1. But the middle number will be 2020 by 4040 means it is f of 1 by 2. Okay. So how many terms are there in total? 4039. Out of 4039 terms, remove this term. So 4038 terms will be there. For every 2 terms you get 1. Because first term and last term gives 1. Second term and second term gives 1. Like that, how many ones you get? 4038 by 2. Because for every 2 terms you get 1. For 4 terms you get 2. For 100 terms you get 50. For 4038 terms you will get 4038 by 2 plus f of 1 by 2. Middle number is f of 1 by 2. If you find f of 1 by 2, what is 4038 by 2? Keep it like that. 2 into 4038 by 2 plus what will be f of 1 by 2? If you find f of 1 by 2, you will get 1 by 2. Then after simplification, what you get this? 4039 will be the answer. Option B. Find f of 1 by 2 by replacing x with 1 by 2, you will get half. So 2 into 4038 by 2 plus half gives 4039. Next, find the domain of f of x is equal to whole power minus half means 1 by root. So this is 1 by under root step x whole square minus step x minus 2. Now we have to find domain for this function. This is defined when the function inside the root in denominator is positive. If you write factors, you get step x plus 1 into step x minus 2. If x minus alpha and x minus beta are greater than 0, then step x will be less than minus 1 or step x will be greater than 2. And we know that step x is always an integer. So what are the integers less than minus 1? Minus 2, minus 3, minus 4 and so on. And step x greater than 2 means step x is always an integer. Greater than 2 means 3, 4, 5 and so on. Now step x minus 2, minus 3, minus 4 implies step x minus 3, minus 2, minus 4, minus 5, minus 6 and so on implies x lies between minus infinity to minus 1. Step x is equal to 3, step x is equal to 4, step x is equal to 5 implies x lies between 3 to infinity, including 3. Therefore, what will be the domain? Minus infinity to minus 1 union 3 to infinity. Same thing can be written as all real except closed interval for minus 3, open bracket for 3. So option B is correct. Option B is correct. Answer is given as A, that is wrong. Option B is the correct answer for this. Okay. There is a mistake in the key given. Step x3 means x lies between 3 and 4. Step x4 means x lies between 4 and 5. Step x5 means x lies between 5 and 6. So x lies between 3 to infinity. Okay. Again, we have a sum of two functions whose domain is required. So find individual domain and then intersection of those two. Either f of x plus g of x or f of x minus g of x. To find domain, find individual domains and then intersection of those two. What is the domain of cos inverse x? X should lie between minus 1 and 1. Here x is x minus 3 by 2. Multiply with 2. Add 3. So this is the domain of the first function. Log of 4 minus x is defined when 4 minus x is greater than 0 or x less than 4. Now intersection of these two gives the final domain. So what is the intersection of those two? X should lie between 1 and 5 and it should be less than 4, which means it should lie between 1 and 4. 4 is not included, 1 is included. Option B is the correct answer. Find individual domains and then intersection of those two. We know that cos inverse x is defined. Cos inverse x is defined only when x lies between minus 1 and 1. This is the domain of cos inverse x. In place of x, we have x minus 3 by 2. Okay. Next. Given that function is onto, f maps a to b is onto, such that f of x is equal to, then a and b. What is the first set here known as? A is domain. And what is b known as? Codomain. But given that function is onto means, f is onto means, codomain is nothing but range. So indirectly, what is the question? So B is the codomain, which is range. Finding A and B means finding domain and range. That's it. How to find domain? Mod x minus x should be greater than or equal to 0 in the first case. In the second case, mod x minus x should be greater than 0. So what is the intersection of these two? What is the common condition? Mod x minus x greater than 0. Which means mod x greater than x. Mod x greater than x is true only when x is negative. It is this is already we did. X negative means minus infinity to 0. This is the domain. So A is minus infinity comma 0. Next, what is range? See, given function is in the form of x plus 1 by x, right? These two are reciprocal to each other. So already I told you x plus 1 by x is always greater than or equal to 2. Implies what is b, which is range. So what is range of given function? Because if we look at given function, the first function and the second one are reciprocal to each other. And x plus 1 by x is greater than or equal to 2, which means range is 2 to infinity. Greater than equal to 2 means 2 to infinity. So b is 2 to infinity including 2. A is minus infinity comma 0. Answer is option B. Remember, any function plus its reciprocal is always greater than equal to 2 when it is positive. Already I gave that point earlier. Set A is given, f maps A to are given, f of x is having 3 values depending upon x, then what is range? Range is nothing but set of images. What are the elements in A? These are the elements in A. Images means image of minus 4, f of minus 2. Image of minus 2, f of minus 2. Like that, find all the images, and we know that range is nothing but set of images. Minus 4 lies in which interval? Last interval. So 2 into x minus 3, which is minus 11. F of minus 2. Minus 2 lies in second interval. So minus 2 whole square plus 1, which is 5. F of minus 1. Minus 1 lies in again second interval. So minus 1 whole square plus 1, which is 2. F of 0, second interval. 0 square plus 1, 1. F of 3. Again second interval. 3 square plus 1, 10. And finally f of 5 lies in first interval. 3 into 5 minus 1, 14. So as per the definition, range is nothing but set of all images. So minus 11, 5, 2, 1, 10, 14. This is the range. Option A. Next question. The domain of the function. Again we have sum of two functions. So find individual domains and then intersection of both. What is the condition for first function? Log of 1 minus x base 10 should not be 0 and 1 minus x should be positive. From this 1 minus x is not equal to 1, so x should not be 0. And here x should be less than 1. And for second condition, x plus 2 greater than or equal to 0, which means x greater than or equal to minus 2. So less than 1 and greater than minus 2 means what is the domain? Between minus 2 to 1, minus 2 is included, 1 is excluded, minus 0, which is same as minus 2 to 0 union 0 to 1. Option D is correct. What is f of minus 1? When x is minus 1, function is 3x. F of 2, when x is 2, second one 2 square. F of 4, 4 lies in the first interval, 2 into 4, 8. So when you add all this, what you get? 15. F of minus 1, minus 3, sorry, minus 3, this is minus 3. So by adding all the 3, you will get 9. Option B is correct.